session. We've got two speakers. One is now happening, and the other one will be online. So we invite Professor Nguyen, who is the professor of digital communications engineering at our host campus, which is Middlesex University at London. And he's also the director of the London Digital Twin Research Centre, who is the sponsor of this event as well. So he leads research activities in digital twin modeling, 5G and 6G systems, machine type communications, and machine learning with focus on Industry 4.0, critical applications. Some recently stroke care, so digital twins for medical sector. Quite extensive, and in terms of outreach, the projects that he has secured are in Vietnam, India, Malaysia, and other countries. So and of course the UK as well, and quite a few industry-funded projects, and published over 130 plus peer-reviewed research papers, and he is also chair for quite a few high-impact international conferences. So let's welcome Huan for a talk on digital twins for IoT and 6G networks, which will very well complement to the previous two talks for Edge AI and the Rescue project.
Thank you, Prof. Maybe I use this one. My voice is quite a bit soft today, so I need microphone. Great to see some old friends and some new friends as well coming over. And thank you, Prof and Ramana, for organizing this. Is very good events so far. I know that people are busy, so if you get people together both here and online at this time of the year, it's very good. So Ramana, Prof, and myself, we work together in all this with the London Digital Twin Research Centre, quite a few projects. So a lot of work in here, a lot of things I'm talking also that their work as well. Just on behalf of them, maybe I can call them over to also join me speaking on this. Okay, so this is a bit about myself. So the background that actually we came from the group that we do a lot of telecom work. So if we talk about 5G, 6G, IoT, we also that kind of the research group. And just only the last 5 years, we moved to also, when we say move, but we don't just leave behind 5G, 6G or IoT. We just expand to one of the research areas that is digital twinning. And that's why we founded the London Digital Twin Research Centre. So kind of that we cover both that research group and that research center as well, and some of the work that is overlap between the two. Okay, and also nice to see Mohammed here. I will come back to Mohammed because we did have some connection now work together in some of the work I'm talking about here today as well. Okay, so the research center here, as you can see, Prof already mentioned about that we've got a variety, a range of different application domain. Even though at the core of our research center is digital twinning, but you can see different applications in different areas. And sometimes internally we said that maybe we expanded too much in different areas, that maybe we very quite light in terms of the personnel in each project. That we would love to have maybe focus more deeper. We need to have maybe we wanted to have one more postdoc working in that project, this project here and there. But still, a lot of the exciting things we did, and that's a good thing in here, and you can see that different domain. Now, so I think I may skip what the digital twin and things like that very quickly, but you can see that you may hear people talking about a number of different concepts, like from Apollo 13 and so on. I just skip that part, but you know that the digital twin terminology is just picking up from around 2017, 2016, right? And a lot of interest around that. And only 2019, you can see that Gartner provided the digital twin as one of the technology trends in there. Okay, so for myself, I think I defined the three pillar technology trend that The very first one is that the boundary between the real world, the physical world, with the digital one, or we call the virtual one, is the boundary becoming very blurry nowadays, right? Because you mentioned about the digital twin, VR, AR, XR with the support from AI, and even now the metaverse and so on. What will lead to the other two pillars? You can see that a lot of business opportunity happen there. But if that's the case for us as the engineering and technology fields, we need to make sure that we engineer the trust into our client, customer, everyone that is doing the digital business, because there is always inherently the digital risks coming with that, right? So a number of different areas that you can work on over there. But let's just focus about the digital twin today for that. Okay? And let's skip this bit of the definition. I assume that so far because I presented this one. I repeat myself enough that some of you already know what the digital concept and so on. Okay, we have some of the very high-level papers talking about the digital twin concept, including the survey, comprehensive survey actually, from our research center on this. And one specific one is about the digital 5G and beyond. Which one of the very first paper, I think so, 2021, about the concept of digital for 5G and beyond. Okay, different application layer, but let's go straight into the 5G and 6G. You can see. I believe that why people think that this thing can be used or maybe can be leveraged for 5G and 6G here. I believe that in here, 5G, 6G availability, as someone just mentioned, maybe Arian, just mentioned that it's mainly limited and complex. Some of the countries that still don't have 5G yet. And a lot of the countries that just, okay, they roll out 5G, but it's not full potential at all. Nowhere near the level of full potential of 5G benefit and so on. And it's expensive, not easy. As a country, especially developing country, you have to choose what's the right thing to do for the country. The investment is huge, and so on. And that is something that we think, okay, then maybe digital twin can be a candidate for this. We can do a lot of trial and test bed in the digital domain, in the digital twin for that, and why not? And if you worry about security, then you can always get the digital twin of that as a sandbox, and to do all the things you like, do all the trial and proactive methods for cybersecurity in there. And if you talk about 6G vision, I think that you heard a lot about the vision, the connected intelligence example, complex networks, the network, extreme user experience, or trustworthy and sustainability, that all align very well with this twin, right? Connected intelligence, because one of the key property of the or key concept of this twin is that you bring intelligence into the system there, right? The only thing for 6G, it is like for the wider society, large-scale deployments of intelligence in wider society. If the 6G, you got a complex network, not just a single thing, not a single network anymore, then this twin exactly for that, a system of the system concept. If our system is too complicated, very large, very challenging, then that is what digital twin is about. And then the same thing for the others. So that's why people think this maybe that actually this thing can match the 6G vision very well. That. Okay. So if it goes to a bit more detail of the benefit, you can see like it's all about validation time. You accelerate that validation time. Sometimes you got the new use case from the time from the idea to the market, right? If the time is quite long. That maybe in the land nowadays now, we need to shorten that from months to hours or even minutes at the idea. So that you need to be able to do that. If you want to do that, absolutely you have to be very accurate this twin of the system you are trying to replicate or also network trying to replicate. You can do the test bed trial in there, validate in there if the concept, the new use case is accurate for you. So, and also that it's about the sharing the validation test result between the development and operation. That become now just minutes of that. But I think that's the most important thing in deployment goes. If you have rolled out something, you always have to trial it. And the trial in reality is very expensive, but we can do that with the digital twin. Because a lot of us that we're talking about the algorithm optimization and doing here and there. But when you do the rollout of the new 5G, even 4G, 5G, and 6G, the same system, you know that you have to go install the new antenna tower and all the facility come with that. And that is quite expensive. Just me, all the network operator, mobile operator, that they really care about that. But that location is accurate for you to install a new facility, new antenna towers in there. There's a lot of things to be done, and you have to try it out. And then I think that this thing is perfect for that. Okay. And then it is not about just saving costs, and then about active assurance and maintenance and so on. So if you got the virtual 5G, 6G network infrastructure, you can always find the potential issue beforehand. And of course, if the discipline is all about the automation and optimization, which is, I think that we will present a little bit later about the Open RAN as well. Network slicing, and that's multiple slicing part as one, for example, that one thing. Okay, so then what this thing can do for 5G, 6G then, and some of the key words highlighted here, you can see real-time tracking of the network changes, right? Would allow the AI tools to simulate and predict the future of this event. For example, you can do the rollout of 5G, 6G, trial of that virtually, so on. And I mentioned about sorting the time to the market and predict the potential performance bottlenecks. That's okay as well. Okay. And one of the, I think someone just mentioned earlier about the traffic generator. I think that nowadays still actually quite important. You may think that is very fundamental, but a lot of that when it comes to new network, understanding the traffic behavior and generate the accurate traffic model for everything is another important thing actually. And you can do that virtually. That's great for you to do the test bed trial and so on. Okay. So this one I mentioned about the project, one of the very first use cases. I mean, move that. That is a project I just mentioned on one of the researcher working deeply in that UKI, FINI, that is a UK India Future Network Initiative, which we're lucky to be part of that now. And then in that we have a project that focuses specifically on the digital support deployment operation of Open RAN for that. Okay, so now, what did you do in the, lost this one again?
Just use the one.
To wrap it in the laptop. Okay, but now, yes, okay. So in this, video to now, we talked about Open RAN and in Arian, right? Yeah, or someone talk about that Open RAN and a lot of concept in that. Oh, I'm actually, yeah, the one after it. Okay, so the thing is that Open RAN, people talk about that, but it seems very challenging actually. Get all people together, agreeing on all the common interfaces, and then everything. And then even that we think that this is an open interface, Open RAN, should be have the standard one, but there's still different kind of the direction people are going for. SC, the software community, go for different open source, and then another community go for different thing. And then it become quite, it's not easy to work together, that thing. And at the same time, there are many other things that we need to do. So in here, we provide a kind of concept level for that, what we think this thing can do, because we understand that, okay, this thing try to replicate the physical system, right, as accurately as possible, and then try to do everything you like in the digital system. including predicting things, testing things, validating things. That's what we try to do. But how can you replicate the open environment accurately? That's not easy question. So that is the idea there. So we presented some of the high-level concept in this from the project we work with different team over there. I think with the Muhammad team as well, from Anglia and from Siri, the 5G, 6G now, center, innovative center over there. Okay, so what we propose in this very simple. There are two approaches. Very first approach is the complicated one actually. You try to replicate the whole RAN system. Everything you got in the physical urban RAN system, I will try to replicate the whole of that. Okay, so you can see very simple. This is the open RAN, and this is the twin of that. With the live data connecting that, and then I can do everything and then do the recommendation. Very standard, this thing concept in there, right? But how can you replicate the whole open RAN? Okay, and even that open RAN is the ecosystem still under development, a lot of things there. Okay, but that's fine. So we propose, okay, my approach that go for what we call hierarchical architecture. Go from the low level and progressively moving to the more complicated level. So in this case, you start from the level 0, this is the twin, where you focus on maybe the single slide, for example. Only focus on resource management of the single slide for that. The level 0 also represents the low level of fidelity of the digital twin. You don't have to ask for the high level digital twin, complicated one at the beginning. Start with something simple, representing the open RAN in that sense. And then you gradually moving into the next level, level 1 digital twin, for example. In that case, you can take care of the whole, maybe a little bit more in terms of operation, orchestration of multiple slices, for example, in that. And then maybe finally, we can define the next level would be more complicated one, more comprehensive one. 2 digital twin, for example. Take in here. So I can give you an example here, right? Why the level 0 just focusing on a single slide example. So you may do some very basic function like data enrichment, traffic flow modeling, or resource allocation in a single RAN slide, right? And level 2 and level 1 moving into maybe a lot more slides. So operation orchestration of multiple RAN slides. Adding further function like load balancing or network security to that example. But the level 2, you will do maybe a little bit more fancy functionalities like prediction, optimization, maintenance, for example. So even that energy efficiency, planning, and reorganization of the cell, for example, automated RAN deployment, all that thing, that should be included into the level 2 digital twin. Okay. But that's not easy. That's not easy to do. So the second approach that we propose that this twin just as the building block for the open RAN. So the open RAN already there. I am just adding maybe one block of this twin in there. So the great about this approach that all the interfaces there already. You're not going to propose new interfaces, right? You should utilize all the interfaces you have to A2 or O1 and so on in there. Okay, so and you see, for example, one example in here, I think it's Ahmed or someone, the second speaker, right after Arian. He already mentioned about architecture of the open RAN over there. So we can just maybe add a bit more to that. For example, in this case, one example, we propose that as a building block, I may start with the digital twin concept within that what called near real-time rig in there, right? So if I have one block in there, the great thing is that all the architecture, for example, R1, A1, or maybe communicated to the E2 over there, to the CU and DU units in there, that are already there, well-defined. I'm not going to change any well-defined interfaces from the Open RAN. So that's why it will be much quicker, easy to integrate to that. The only thing that what can you do with this within the discipline here, let alone that people may have concern about that, oh, you are in the RAN system actually, you may consume the power resources of the system already there, which a lot of people may not like. Okay, so at the same time, okay, maybe the near real time a little bit too much because its requirement is much more strict. You can move into that non-real time component. So I can move the distinct component supporting the machine learning training and everything in there. I generate the data from the machine learning training in, for example, in the non-real time brick component in there. Okay. So that is another concept, the benefit. Or another one we think that is possible, so that we put this thing absolutely outside of the rig component over there, not in non-near real time, not neither in non-real time over there. So it's outside of that. Just like one of the CU and EU did in relation to the RAM intelligent control component over there, right? So that is the kind of the architecture we propose that. Okay, so that is the concept we propose, and still a lot of work can be done. We stand further of this, but we talking to Mohammed to see. But we get the next phase of the project. We can work on that much more detailed validation of all this concept to see how it works. And even some of the XRR in there, if you can design as a machine discipline as an XRR supporting different interfaces. And the efficiency, one of them, traffic steering, anomaly detection, for example. A lot of the other applications you can do as well. That can be very exciting use cases to validate our concept. Another thing, more about this thing, but in relation to the IoT concept and in particular industrial IoT. So this is one of the work also from the UK IoT, that which Prof and Ramana project. What's today workshop, right? When we got the previous one between the UK and India. So we got. We have the lucky we have this facility of smart factory. So in this smart factory, we have the just a mock for training, but it's real of the mobile phone production line. Okay, so around that we got around 50 sensors measuring different type of things, pressure, temperature, and so on, many different things. And so that is something we can read the data from because it's in our lab. We can control and then we can test. Sometimes we don't want to read wirelessly. We can even connect the cable to read the data to verify things and so on. And so I think that all brilliant in that is great for us to build a digital twin of that. Okay, and that's exactly what we did. You can see this on the left-hand side, two islands, right? One island taking care of the back of the mobile phone, insert the circuit to that, and use a remote to connect to the other islands to apply another cover, the rear cover or the front cover of that mobile phone and finish the job. Okay, and so we build the discipline of that exactly there. Okay, so how we build this one? I think we start from actually also a lot of the things. We start from scratch. For example, it's all about collecting the data and monitoring things in real time. So that's a bit we started with. We think a lot that that's a key thing. For the 3D component here, we have to admit that we get some support from Festo. They got to provide some of the library for us to use. We just use some of the existing 3D modeling and combine them using the Blender, for example, plus with the Unity engine, and to get everything together to get the 3D models here. But for the sensor, our approach is that we create what we call virtual sensor, and our approach is matching this virtual sensor with the real sensor. That's the key thing for us, to be able to monitor and matching things here and reading the data. Once you got the data, and particularly in near real-time basis like that, that's just the next step. You can use all the AI, all the machine learning, everything you like for the bring the intelligent bit into this system. That's what we call. can be prediction, can be anomaly detection, or can be the predictive maintenance. So this is the PDF, but I think we can show you the demo of that slightly later towards the end, where we can click on this link and then we show that the top bit is the real system, the bottom bit is tracking almost in real time what's happening in there. Okay, and then the framework also, as someone mentioned about the edge layer, you mentioned that it's very nice that we also have the concept within our district where you cannot do everything in everything in the cloud layer, for example, especially with the federated concept of digital twin, and we will move something to the middle layer, host layer, or edge layer to do some bit for us. Some thing that in there, like you can change the machine learning model in the edge layer, support the concept of digital twin. So I can relate to that what this topic has been talking about. And now I'll go a little bit more fundamental, because I mentioned that in our system we have around 50 sensors. So assuming that in the more complicated scenario where we have 100 or 1,000 IoT sensor in there. And so the concept of that, okay, we propose in the smart factory like this, where you got multiple different manufacturing processes in there. Each of them would have a number of different IoT sensors, right? So the job for us is that it's all about the machine health monitoring or anything as a system here. We make sure that everything is working well, right? If some of that not working well, what will happen? How can we report that? How can we recognize that? Okay, so all the sensors actually they are doing the main thing for them. That send information, send the data back to the fusion center or control center. But our approach is that we utilize the sensor to send the secondary information to that, which is about the status of the machine health. Here. So, for example, how can we do that? Okay, you are sending the information about temperature, for example. That's fine, you keep sending that, no problem. But I ask you to modify the level of power to inform me something is not right. Okay? If you send with the normal level, designated level, the power, then that's nothing happen, right? But if you reduce the power by a third or maybe by half, then I know what's going on. Okay, I know, oh, this is something wrong, right? But it's not easy to detect that. However, if you got like 150 sensors together doing the same thing, you can recognize things, right? And to do that, you have to utilize also deep learning approach, for example, to recognize that. And we, in this case, that we realize that we recognize the shape of the wireless signal like this. For example, you got the drop level power like this. We think that autoencoder is a great tool to recognize this kind of shape. Right? You got transmit normal, suddenly you have drop level power. Whereas this one is normal, right? That's another indication. So we just maybe do for validated concept, we just divide into the 3 states. One transmit with the power level P, that means nothing happened and everything is working well. We call that set in G example. But the amber level, that means something is not right. But the system is still working, but you need to pay attention. Then we reduce the power level by a coefficient alpha 1. And then if something really not right, you need to stop the system straight away at the red level. Reduce the power level by alpha 2, right? So that is the thing. But how do you recognize those things? Is that because the wireless environment that you got the drop level power? That's very much the case as well. Or is that the deliberated drop of power because something wrong there? So that's all about the detection at the end, right? So what the detection or the accuracy of the system in there. So you can see here, you can see that in autoencoder, you see that the middle layer level, if we need to put a number of features, that's the minimum number of feature in there, right? And if we choose in this case, it's the 80 feature in there, so minimum 1. Then the accuracy level was very high, almost 900% level. If you reduce half of that, only 40 feature in there, then it's still okay, almost around 90%. That's still respectable level of accuracy and so on. That's the example of that how we apply the concept of or IoT. Another direction we work for that is reducing the support of risk. Also, some of the previous speaker mentioned about risk, right? I'm not going to copy that, but again, in the concept of what we are applying here is for smart factory. Now, it's a risk. You can always in this concept that if you want, for example, imagine that in a big factory like this, you want to send a control signal to all the sensors, maybe to set up something or change something for the whole system. Then that the nature of that is the broadcasting environment, right? Right. But it's a support in the future because in the smart factory, there's not a way to be able to send that directly to all the sensors to make it work. Then you may have to employ that the risk architecture there. Then they will send the signal to all different clusters in there to work that. And then also for this, you come back to the traditional method that how to maximize or minimum the power, the energy spent on that, or maximize the rate we transfer, and so on. That's another direction of work we have done within this view of the smart factory with the concept of digital twin. Again, with the deep learning method, we do. I think maybe I've skipped this all the detail in there. And as a second project, we did at the London Digital Research Center, and then also that supporting the critical IoT structural health monitoring. So I think I didn't put the video here, but in my country, Vietnam, just a couple of days ago, there are a famous video showing that the collapse of the bridge. You know that we see that unbelievable people are traveling on this bridge. Down there, it's very strong current of the river because the flood of the big tornado and we call it hurricane. Is that hurricane called Yagi, hitting the country of China, Vietnam, and that region. And afterward, it had a lot of flooding, still a lot of raining over there. And right now, currently, there's a lot of damage to the country. And one of the famous videos showing about the collapse of the bridge because of all the consequence of the storm and so on. The people just suddenly just collapse into the river because they are middle of the bridge. And then you see someone can record that, unbelievable. So another thing you can see in this one, I don't think I can play video because it's a PDF, but also this bridge is collapsed suddenly. That's what we want to see. And the Hammersmith Bridge in London here has been also that, the 4 column here, there are some structural problems. Without detected, now it has been closed for repair for almost 5 years, causing huge disruption to the local community. So structural health monitoring is very important, and this thing can support that. So you need to have all the IoT things to collect the data, make sure we can develop a digital system to support that. And that's what we did with another project funded by the Newton Fund a few years ago, actually, to do all that thing with the partner country from Vietnam. So we go around the country, collect the data from different bridges. And one of the key highlights in this project that we help repair what is we call the Thang Long Bridge, connecting between the international airport in the capital city of Hanoi to the city. There are always problems at the issue with that bridge. Decking keep having issue problem. They keep repairing all the time, but there are always something that's not right. So we help them by building a design of that, finding the optimal solution of the decking with the material, and then testing by building a portion of the bridge in the lab. So it's just like a portion of this bridge, applying different things to that, including the forces of vibration, the condition, the humidity, and so on, and then testing all that with the data from our design model, and then come up with the right solution for them, which has been now a few years without any problem. So that's a good thing from them. And saving a lot of money, saving repair time for that. Okay. But in this kind of the project, again, AI and deep learning still has been used a lot in that detecting, because anything with predicting, forecasting, supporting, then that is a key. That's a key thing that this thing can offer. But then this thing also need the core thing that the AI and machine learning or deep learning to support that. Maybe we have quite a few projects in different areas, even healthcare, Prof mentioned, but I think this may be the last one I wanted to talk about because it's related to the concept of using or wireless sensor and so on with concept is fit. So that's another project for smart farming agriculture where you deploy all the IoT to support the automation for monitoring and control and operation of smart agriculture concept. In this case, we focus more on vertical farming, right? Like in the urban area, you don't have a lot of space to grow things, grow plants. So you can do that in very tight space, and that may need you need to set up the IoT system to support to monitor things there. And that project is exactly about that. Okay, and then we set up a lot of IoT from both sides, and so the concept is very simple. You know that you got all the sensors collecting things here through the IoT gateway, and go to the server in the cloud server over there. You may think that this normally we should use the MQTT platform as normal thing, but you know that's the idea. But sometimes during implementation, it's not easy, and there's a lot of delay, and then especially when you don't have a lot of the sensors, or not thousands of sensors, right? Then actually you may go away with something using a simple thing, like even HTTP protocol to support this, to send the data to the server. And Prof and myself traveled to Vietnam using that to validate all these things. So we also with the database server there, we develop the web app, then utilize the AI model in this. And all the structure is there. But then with the project finished, and then suddenly the personnel we need to move on very quickly to another project about healthcare and so on. So that's another thing. If we have the chance, we would love to go back and then do something further in this. Okay, we wanted to further develop all these things. Make sure that the smart farming, because there's a lot of interest in Vietnam, and even in the UK here, I heard in the last year, the government called for 20 projects support smart farming in the UK, and we can overdo that. This is just the web interface we develop for that. We'll see everything we see. For example, we can from here in the UK, we can monitor the farm in Vietnam, in the UK, on real-time basis. Try everything. If there is not enough humidity level, we can turn on the steaming system over there automatically. So you see, how can use the camera to detect the growth of the plant over there? It only very basic concept, but that we try to prove that and a lot of things can be done in automation way for the smart farming. Right? So the camera, even this camera, is not very high resolution camera, but that's good enough for some of the detection here. Or we can also develop the concept of you can grow things in the old kitchen, with the support of the IoT devices in there. Okay, that in our lab maybe still there. I don't know that after the summer we haven't looked at that. Definitely. So it's some of the photo highlighted. It's still there, Prof?
Still there, yeah.
I think
Any plan in that?
Yeah, there's still
onion.
onion is there,
Okay,
garlic is
that's
there.
nice. Okay, so with that, I just conclude here just to highlight some of the things that we at our London Digital Research Center, we have some practical projects developing different things. I know that still a lot of things because the key thing that we need to bring the concept of the intelligence into that digital system, and some intelligent bit that we're still missing or we want to develop further, that open a lot of the opportunity for cooperation, further work in that. And even there's some farm here in Vietnam, in Ho Chi Minh City, we visited and work with them. You see that a lot of things here can be done in automated way. Okay, so see that when we come, we realize that underneath this thing, because they got a bit high level, they got the water to support all this plant, right? Underneath here, actually a lot of the the water, the humidity is very high, very wet in this kind of very humid. And that's not good actually for in this kind of tropical country. It builds a lot of potential disease. That's something we don't recognize here in the UK. And then coming there, talking to them, understanding that, then it's a very simple thing. You just install the sensor to detect the level of humidity and so on. And then you install the fan
And the very basic funding way that turn on the fan if the sensor hit a certain level. That's simple thing, but it work well. So you don't need a lot of people to run this kind of the small farm. But it is very good farm supporting a lot for the city of Ho Chi Minh City, which is a big city. And that. Okay, with that, over time.